data extracted from, let's say, a differential pressure gauge in the field. But this is raw data, really raw. We want to import that into Excel, clean the data, because the data has a lot that we need to remove. Actually, we need only few data. And I created the problem in such a way that we have to discard a lot of the data before we can use it to do what we want to do. So that would be very nice. Then look up values in tables. This is something that we might not do today, but I'm going to show you that as well. Then using formulas and functions. We need to learn how to use formulas and functions. And then we need to learn how to prepare charts. So I'm going to prepare one chart for you to see. All right. In importing data, we want to learn how to import data from text files. And I'm also going to teach you how to type data manually in Excel. These are things you know, but importing data from text files is a bit new to some of you. Then in cleaning data, we will learn how to remove weird characters, sorting data, filtering data, converting units. We can do that as well. And then looking up data, we have lookup, VLOOKUP, and HLOOKUP. And using formulas and functions. I mean, that is very fundamental for an engineer. You need to know how to use formula to calculate stuff. So using Excel inbuilt formulas and functions, creating your own formulas to solve problems. These are all things that you have to learn to do. And we are going to try to look at some of them. Then preparing charts. You need to learn how to prepare simple charts and format the charts to meet scientific standards. I've already been repeating that most of the default charts and figures and tables that you get in Microsoft Office are not ready for engineering use. So you need to work on them. And that's what we are trying to do here. Okay. I think apart from this, we can look at the problem. This is the problem. You will be given a text data file containing a lot of data. Import the data into Excel and clean it up. Use the Darcy equation and the given data to compute permeability. Plot the calculated and measured permeability on the same scatter plot and format it to meet publication standards. Fit the measured data with a trend line and display the equation of the trend line on the plot. Now, let me show you what this work is about. Permeability basically expresses the ability of a rock to allow fluid to flow through it. So if a rock allows, let's say, more oil to flow through it per time, we say it's highly permeable. If the rock does not allow more fluid to flow through it, we say it is less permeable compared to, let's say, the first one I described. Now, we pick these reservoir rocks, we bring them to the lab, and we try to measure the permeability to see how good the rock is in allowing oil or gas or water to flow through it. And when we bring it to the lab, this is what we do. Basically, we have something we call a core holder. So we put the rock inside the core holder here at a certain temperature and pressure. And then we flow some fluid through it, mainly brine, okay? That is water containing some salt. So the brine goes into the rock, and then we measure the pressure drop across the core. So this is delta P, pressure drop, the pressure difference between the inlet and the outlet. Now, with knowledge of this flow rate, the rate at which we injected the brine, and the pressure drop across the core, we are able to calculate the rock permeability from a formula we call the Darcy formula, or the Darcy equation. Darcy, okay, it's expressed this way: Q Ka over mu delta P over L. Now, the A here is the cross-sectional area of the core, and this core is often cylindrical. So we can basically calculate the cross-sectional area of the core where the fluid is going in. Secondly, this mu is the viscosity of the brine we are injecting. So it is something we know. Then the Q is the injection rate, the flow rate with which we are injecting the fluid, excuse me. That is also something we know because we can set the pump to a constant injection rate. Then the L here is the length of the core. Often we know it's about 7 centimeters. Okay, so what we don't know here is K delta P. And the good thing is we can attach a differential pressure gauge here to measure delta P. So in the data you are given, we've measured delta P. We have 3 differential pressure gauges in the setup that we use to collect the data that I'm going to give to you. So we have delta P1, delta P2, delta P3. All these delta P's, the one that we are interested in is delta P3. Delta P1 and delta P2 is giving us the pressure drop across different sections of the core. Delta P3 is giving us the pressure drop across the whole core. That is what we want. So once you have an idea of that, you understand that we will get delta P. So we put delta P in here. We have our Q, we have mu, we have A, we have L, and so we can calculate K. Now, the instrument we are using to measure these data also calculates its own K, but we don't trust it. So what we are going to do is we are going to take the K that the instrument has read, in this case, a pump. The pump has also logged out some K data. So we are going to take those K data, and then we are going to use the delta P to calculate our own K permeability and compare it with the one that the pump has given to us. Then we can make an informed decision to say, okay, the pump data can be trusted or not. If it is consistent with what we are getting, and we see that the values are very close, then we believe that the pump is doing a great job. Otherwise, we will rather trust the delta P calculations than the one that the pump is giving to us. All right, so that's what this exercise is about. If we had a big lab where I was going to demonstrate this for us to do it together, I think we will all enjoy this exercise. It's such an amazing exercise. But unfortunately, we have to do it this way. Let's see how the Lord will help us to be able to do it well. All right, I'm going to go into Microsoft Word to show you a few things there before we delve into this data analysis. Okay, if you can see my screen, last week, this is what you did. And most of you did very well. So I'm really glad that most of you were able to work on the assignment. Now, if you go to the toolbar here and you click on the tab Review, okay, this is what you see. Now, there are a few things here that are very important. To review work means that, let's say you have written a report and you want me to read and give my comments. Or I have written a report and I want you to read through it and make corrections. You use the Review tab to do that. Now, the first thing you see in here is new comment. So let's say you've written this abstract, I've read through it, and I have some comments. I can just highlight, go to new comment, and then I can add a comment and say that, okay, you did a great job. For example, you did a great job, but please add a few more lines to describe how your work can be useful to Ghana, for example. This is a comment I've added. So if I send the work to you, you can see this comment and you can follow it through to make correction to the work that you have sent to me to comment. Another thing I can do is to make changes to the whole work. Let's say I'm going to edit it. To do that, because I'm not too sure you will like the comments I'm going to give, I'll use a tracker. So you see in here, we have track changes. So I'll just click on that. If I click on that, everything I'm going to do will be tracked. And when I send it back to you, you can choose to accept my comments or not, and the document will not be affected. So let's say I've added track changes, and now I'm going to type. Let's say Ghana, or let me just go in here. I'm just going to type here, God bless our homeland, Ghana. See that a red line here has been drawn on that side because I activated these track changes. So once I send the document to you, you can follow these trends and you'll be able to know where I've made changes to the document. Now, you also have the option to accept or reject the changes. You do that using this accept tool here. So you can go in here. We have accept and move to next. Accept this change, accept all changes shown, accept all changes and stop tracking. So when I send the document to you and you receive it, you can go in here and you can decide to accept the changes that I'm giving to you, I've made in the document, or you can choose to reject it and it's not a problem at all. All right. Another thing you can do is to compare documents. So let's say you are working on an article similar to the one that I have right before me here. Usually you work in drafts. So let's say the first document you write is a draft. So let's call that first draft. After that, you make additions and you do editing and you add stuff and you add stuff. That becomes a second draft. So you have draft 2. Then let's say you send it to your co-authors, they also make some changes. That becomes a third draft. Then when you are done, let's say you send it to a senior colleague who is an expert in the area to read through. He also makes some changes. Then it becomes a 4th draft. Now you are heading towards the final article or the final publication. Let's say you want to actually compare the work you have done. Let's say a senior colleague edited the work. He didn't tell you exactly what he has added or taken away, and you want to compare to find out what he has done. You can just use this compare tool here. You can use it to compare the work that you have done and the one that he has edited. And it will show everything that he has added to the document. So that is a very powerful tool to use, compare. And then you can also combine 2 works. Let's say if I've worked on draft 1 and draft 2, and they are different, and I want to actually compare and just combine the 2 into one document. That can be done using this combine tool. You can also protect the document. You can lock the document. You can restrict editing so that no one will be able to edit it. That's something you can do here. And then here you can reject changes and all that. So these are some of the things you might want to look at. For more of this, you can check YouTube, you can check Google. I think you will find a lot of videos on these kind of stuff. That is quite very important for especially for those of you who work in groups. You write stuff and send to your colleagues to check through. And when they check through, they can make comments and send it back to you without printing stuff. All right. Since we don't have so much time, I'm going to end this here. The table of content and the list of figures and all that, I wanted to really add them, but the time. So what I'm going to do is I'm going to find a very good video and send to you to watch so that you can learn that by yourself. Okay. Now let's go to Excel. First, let's look at the data we've got. Go here. Okay, this is the data. So I'm going to go and show it. Okay, this is the data I've given to you. As you can see, well, the language, some of the language is in Norwegian. Datu is date. Klokka is clock, is time. Yes, that's Norwegian, so it's not a problem. We are even going to remove all those data, so it's not a problem. Then we have this time, but what we are interested in is the injection time. So we are interested in the injection time. We are interested in the permeability that the pump has measured, and we are also interested in the delta P3, which is the pressure drop across the core we want to use to do our calculation. So a lot of this data will have to be removed. All right. Now, this is an overview of the work that I have done. We are going to do everything over, so don't worry about this. The chart we want is going to look like this. Okay, so this is what we are going to prepare. But we need to start from somewhere. So don't worry about this. All right, let's get into it. So I'm going to create a new tab. Okay, this is a new tab. And then I'm going to import the data file. So I'm going to go in here, File, Open. Okay, Open, I'm going to go Browse, and then I'm going to look for the data. So I've kept the data in this folder, P4. Now remember, when I open P4, Excel doesn't show me the data because the data that Excel by default will find in the folder is Excel files. So I have to change this to all files, and then the brine permeability data will show up. So then I'll say open. And when I ask it to open, this is the dialog box I see. Now, most of the work will have to be done here. If you don't do the work here properly, you are not going to get the right data. Now, the data file I've sent to you is a delimited text file. So we have delimited text file and fixed width text file. Delimited text file has characters such as comma or tab separated, separating the various fields, okay, or the columns. But fixed width files do not have this. Okay, the fields are aligned in columns and spaces between each field. So what we have is delimited. So please, if your PC does not select delimited by default, most PCs will select delimited by default because it can actually read the file to know that this is a delimited text file. Okay, so select delimited, and that is enough. You just move to the next. Now, when you move to next, select tab because the columns are separated by tabs. If your PC is smart enough, it will be able to select tab without you having to do it. Then I think that is okay. You move to next. And then this is where you specify the data type and the data you want to import and those you don't want to import. I already said that we are not interested in the date. So for date, I'm going to say, do not import column. Then I'll come to clocker or the time reading at the time. I don't need it. So I'm going to say, do not import column. The time is important to me. So I'm going to keep that. And I'm going to keep the data format as general. The flow rate is not important to me, so I'm going to say do not import column. The quizzes pressure is not important to me, so do not import. The volume of quizzes pump, I do not need it, so do not import. Then I'll move in that order. Permeability, yes, I need permeability, so I'm going to keep it. And the data type, the data format is going to be general. Flow rate, I don't need it, so do not import. The pressure, I don't need it, do not import, because this is not pressure drop. What I need is pressure drop. The total volume of brine injected, I don't need it. The volume left in the piston cell, I don't need it. So I'm not going to import that as well. So I'm saying do not import. D2, I already informed you that we have 3 pressure drops measurements, DP1, DP2, DP3. We are not interested in DP2 and we are not interested in DP1. We want DP3, so I'll keep DP3. And then the pore pressure is not important to me as well, so I'm going to say do not import. Okay, with this, I have selected what I want to import. So I'll just go on and say finish. And when I finish, the data will be imported, just the data I really need. Get that? That's pretty good. So I'm going to try to make it look great. So I have my data here. I have the time, the injection time. I have the permeability that the pump has measured in millidarcies. And then I have the pressure drop, DP3, also measured. So what I'm going to do is sort this data out. Look at some readings. There were times that the pump couldn't read the permeability, so it read 0. And if you go down, you actually find that there are times that it read negative. So it means something went wrong around those times. These are all data you don't need, okay? So you need to find a way to sort them out. You need to find a way to filter those data out. Well, some are saying they can't see the data. All right. Who can see? If you can see, type yes, because there's data in the, but can you see the Excel file? Okay, then let me reshare. Let's see what we see. Can you see? Can you see? Okay. All right. If you can see, then we will start working. It's rather unfortunate that you couldn't see the importation. Okay, then what I'm going to do is I'm going to import the data all over again so that you can see. Since most of you couldn't see the screen, I'm going to import the data. Did you see the importation of the data? If you saw the procedure, please type yes. The procedure for importing the data. You couldn't see. Okay. Let me try doing that. Let's see. As I said, you just go to File. If you want to import the data, you go to File, Open, File, Open, and then you browse to where you've kept your file, and then Open. When you click on Open, it will bring you a box. Well, so I'm going in here. Let me try again. Open. I'm browsing. I select on this, and then I say Open. Well, nothing is happening again. I don't know what has gone wrong. Let me try a new tab and see what will happen. File, Open. Well, there's something wrong. I'm going to close all these. Don't save. And I'm going to open a new Excel sheet. Let's see how that will work out. Please, can you see my screen? Can you see the Excel sheet? Can you see the Excel sheet? Okay. Let me try importing the data here. Let's see if it will work out well. So what I'm going to do is I'm just going to go in here. I'm going to create a new tab. And then I'm going on File, Open. Well, the data is already here. So this is what I get. Please, can you see the screen now? Okay. Let me go through the process once and for all. Now that most of you can see. So I said that if you open the text file, you select delimited because this is a delimited text file. Then you go to next and you select tab because the columns are separated by tabs. Then you move on to next. And this is where you select the data you want to include in the file. Now the data I want is only 3. I want the time, the injection time, I want the measured permeability, and I want the measured pressure drop. So this is what I'm going to do. I just start from the left to right, and I remove all the data I don't need. This date, I don't need it. So I'm going here, and then I'll click Do Not Import Column. Block, I don't need, Do Not Import Column. Time, I need it. Flow rate, I don't need it. Pressure, of quizzes, I don't need it. Volume, I don't need it. So I move on until I get all the data I need. Permeability is data I want. Flow rate, I don't need it. Pressure, I don't need it. The total volume of fluid injected is something I don't need. Volume left in the piston cell is not important to me. dP2, I don't need it. What I need is dP3. So dP1, I'm not going to log it out. And then dP3 is here, so I need dP3. I don't need pore pressure. So similarly, I don't log out pore pressure. Then I'll click on finish. And I have my data right here in the Excel. Okay, I have realized something, that when it happens, usually it opens in a new tab. That's why you can't see the screen. So I'm going to show, I'm going to go in there and show you what I got from. Yeah, so this is what you get after you have imported. Please, can you see? Yeah, that's great. Now we are just going to go into this and try to manipulate these data. The first thing is I'm going to sort the data out. I said that there are characters here we don't need. These measurements of 0, some are negative numbers and all that. Because it's instrumentation, sometimes you can have power outage. Sometimes the instrument just fails. Look at this data here. This permeability data doesn't make sense. So we have to clean it up. So all I will do, I'm just going to select the whole data and I'm going to filter it. So I'm going to go in here. Control A will select the whole data. So if you hold Control A, you have the whole data selected. And actually you can make an adjustment. You can go in here and just click Control A. You have all the data. Then you come here and you click Sort. Filter. Okay, let me use filter. Filter. Now I can go in here and I can filter. I want to filter from the largest to the smallest so that I can get rid of all the negative numbers and the likes. So I'm coming in here and I say sort from largest to smallest. And you see what I get. Immediately the numbers go from 72 downwards to the lowest permeability I can get. So if you come in here, you see that the lowest permeability data that you can use is about 59. So then I'll go in there and I'll copy that data from from this 72 to where I have the lowest data I think makes sense, which is 59. So I'll copy this data. Copy, and I'm going to paste it somewhere. So I'm going to paste it here. I'm pasting them, I can paste them as numbers. So that's fine. Remember, I still have my injection time, permeability, and all that. I can copy that as well. And then paste. Copy. So I'm just pasting them here. Now remember, this data has been sorted from the highest or the largest to the smallest permeability. Now I'm going to sort them back from the smallest to the largest time, injection time. So I'm going to go in here and I'm going to use Control A again to select all the data. So Control A, all the data is selected. I'm going to sort. I'm just going to put a filter on it, and then I'll come in here and sort. So I'm putting a filter on this, and I want to sort from the smallest time because the injection rate increases with time. So I'm going to do that. Sort from smallest to largest. And bingo, I have the smallest time here to the largest time. And my data is very, very clean. I can see that injection time starts from 0.0858 and goes all the way to 192.03. And another great thing is, although I've lost a lot of the data because some measurements were not good, all the permeability data is clean, and all the pressure drop data is also very clean. So with this, I have data I can trust and data I can use. I didn't transfer anything, I just copied and pasted. So it wasn't any transfer. I opened the data and it came into Excel, and then I sorted it out, removing all the negative numbers and the weird characters. And then I copied the ones that make sense, pasted them, and that's what I'm working on. So I really didn't transfer anything to anywhere. Okay. So now we have our data. We have the measured permeability, then we have dP. Now there are some data that I need to give to you. Those ones are not in there. So the ones that you need to be able to compute the permeability. So I'm going to copy them from somewhere and then I'll bring them here. I'm going to paste them as numbers. Okay. So these are fixed data that I'll give to you, God willing, when you start working on Wednesday. You can also find them in the video. So those data are the diameter of the core, the cross-sectional area, the viscosity, length of the core, and the injection flow rate. These data, you don't need to get them. I'll give them to you, okay? That's what you need to perform the calculation. Now let's see how we are going to do the calculation. I've already written the formula for you. So I'm going to write it here in a way that we can see and apply. The K is just Q mu L all over K, all over A times the delta P. So you have the K, which is what we are trying to calculate, is equals to the Q, in this case, times the mu, or the, I'll just write this to represent the viscosity, times the L, all divided by A times the delta P. Okay, I'll call that dP, delta P. Okay. So this is the formula we are going to be using to compute the permeability. Okay, before that, I'm going to create a column here so that I can calculate the permeability. So, okay, insert, and then here I'll say permeability calculated, perm calculated. And then I'm going to insert the formula here. Okay, so before you type a formula into Excel, you start with an equal to. So you type equal to, and then remember our formula, it is Q times mu times L. So I'm going to open a bracket. Where is Q? Q is right here, times mu. Where is mu? Mu is right here. Times L. Where is L? L is right here. Okay, all divided by A. Where is A? A is here. We multiply that by the dp or delta P, which in this case is this delta P3. So it is this cell. Then we close that. But all the fixed data, we have to keep them fixed. And you keep them fixed by putting a $sign in front of the letter and the number. So if you type a $sign in front of the number and the letter, you've kept that field fixed so that that data will not move when you move to the through the column. So similarly, you can keep this fixed. Then you just click enter and you have this. There's a conversion factor you need to add. The conversion factor is 100. So 100 times this. Great. And then you just put your cursor at the corner here, double click, and everything is calculated for you. Okay. So this is the calculated permeability. Now we want to plot. So what I'm going to do is I'm going to select the whole data. I'm selecting up to the calculated permeability. And then I'm going to go to insert, scatter plot. So I want a scatter plot. I'll just say insert scatter. And it has plotted it for me, but I need to go and do some editing. So what I'm going to do is I'm going to move this chart to a place where I can do the editing comfortably. So I'll right click on it and say move chart, and I'll specify where I want it to move. So I'm going to call this chart permeability. And then when I click OK, it will move to a separate page or a separate cell for me to do the editing. Now I'll go in here, add chart elements, and I'll remove the grid line. I don't want the grid line, so I'm removing this grid line. I'll go in again, grid lines, and I'll remove the grid line. So all the grid lines are gone. Then I'm going to remove the title. I don't need a title. So I'll go to chart title, and I'll say remove, and the chart title is gone. Oops. Chart title, none. Okay, chart title, none. So it's gone. Then I'll go to the axis. I'm going to label the axis. So I'm going to go back. I'm going back to design, and then I'm going to add titles to the axis. So I'll go in here and say chart axis title. I'll add one in here, and then I'll type the axis. This is horizontal axis. So I'm going to call it injection time. Injection time in minutes. I can either put the minutes in brackets, so I'll rather do that. Okay. Then I'm going to add a vertical axis. So axis, I go in here and say vertical, and I'm going to type the name. This is rock permeability. Rock permeability in millidarcy. So MD. Bingo, and I have that. Now, look at the legend. It says series 1 and series 2. So we don't know which one is the measured permeability, and we don't know which one is calculated. So I have to go and modify that. So I'll go in here, and then I'll try to look at the data. Okay. So I'll go to select data. And if I select series 1 and say edit, series 1 will give me the measured permeability. So I'll write here series name, measured K. All right. And then I'll go to series 2, edit, calculated K. Great. So I've got that. Now I'm going to add tick marks to the axis. So if I double click in here, I can go to the axis. I can go down here, and then I'll see tick marks. And on major type, I'll just select outside. And then you see that there's these small marks that points from the axis to the number. Okay, so that's one thing I've added. I'm going to add tick marks here too. So I go down here, and then I say major outside. And then I have tick marks in here as well. Now I'm going to the data. If I double click on this, I want this. I don't want the data to be colored. I want everything to be black and white so that when we print it, if someone download my work and he print it and he doesn't have colored printer, he should still be able to distinguish everything that I've done. So I'm going to go in here, and I'm going to change the marker. So marker options, I'm going to select triangle for this. The size, I'm going to say 8. And then the fill, I'm going to say black. The fill should be black. So I'm going to go in here and say black. So I've changed that. And also I'm going to put a trend line through it, but I'll come to that. Let me change the other data too. So now I'm on this data. I'm going back to the fill, the marker options. I'm choosing diamond. Okay. So diamond, the fill, I want it black. And then I want the border to be black. So I'm going down there, and the border, I'm going to say black. Okay. And I need to also change the size to 8, similar to the other one. All right. Then I'm done. Now, the only thing I need to do is to put a trend line through the data, and that would be great. So I'm going to the first data. I'll come in here. I'll go to trend lines. And then I'll say linear trend line, and the trend line goes through it. I'll come and click on the trend line, and then I can display the equation. So I'll come in here, display equation on chart, and then you see the equation right there. Similarly, I'll go in to this data. I'll add a trend line. Yeah, linear trend line. Great. I'm going to display the equation on the chart, and you see the equation right there. Now, I'm going to also change the color of the trend line. So this is a trend line. I need to work on it a bit. So I'm coming in here. I want the line to still be dotted. But this time, I'm changing the color to black. And I'm also going to make it thicker to 2.25. And then I'm coming in here to this one. I'm changing the color to black. I'm making the line thicker to 2.25. And then I'm going to change the line type to this. So if someone prints this chart, he can distinguish all the lines and all the charts and all the data points without necessarily needing a color. because the trend lines are different and the data points for the measured and calculated are all different. Now, if I push this up a bit, you see the legend here. You have measured, calculated, linear for calculated, and linear for measured. You see that it's all distinguished. Okay, you can also play with the fonts. You can go to the axis in here. Let's go home, and then we can play with the font. Let me say I want to go Arial. I would have rather gone for Times New Roman. Let me say Times New Roman. Okay. I'm going to change that to 12, and then I'm going to make it bold. I can also highlight this and make it bold and to become big. I can change that to maybe 10 or 12. Okay, 11 is fine. I can go in here. I can change this to also 11, and then I can bolden it. I can come to the label, and then I can select Times New Roman and make it 12, similar to the vertical axis. Okay, and I can bolden it as well. So it looks great. All these legends, I can actually work on them similarly. I can come in here, make them Times New Roman, make them maybe 10, just to make them look good. And when you are done, the curve, the chart looks really, really great. It takes a lot of work, but once you are done, you will like the chart. Yeah, I understand this is a lot of work. And because of the time, I went through it really fast. So if you want to do this well, you might need to really go through the video and do it severally. Because I don't want the video to be very bulky. I really don't think it is good for me to go beyond an hour. So that's why I've rushed through the last part of the work. But I'm very optimistic that if you go through the video, you should be able to do these things. There's nothing really hard in here. It's quite very easy to follow. Most of you might probably have experience in doing some of these things, but you really don't know that this is what we want. So I'm hoping that you'll be able to work through this. But on Wednesday, I'll be around, and then we see what we can do with this. Try your hands on it before you come, so that when you come, you fill in the spaces. You don't get to the lecture room before you start to work all over. If you come there with something, then it becomes easier to help you to learn more. But if you come there empty-handed, it doesn't encourage us to want to push you to learn. Well, this equation, I can actually even move it if I like. All right, if you like, you can move it. I think it's not necessary. The other equation is right here. We can also move it if we like. But I don't want to go through that trouble. Yeah, the video will be ready, don't worry. I'm recording into the cloud, so it's going to take a while. Probably tonight or early morning tomorrow, it will be ready. And they'll send it to me, and then I'll share with you. So the video will be very ready. Yeah, the fixed data is important, because if you don't, if the data is not fixed, or you don't have the fixed data, you can't calculate the data, the permeability data. So you need to have it, and it's in the, it will be in the video, so you can type it. On Wednesday, I'll write it on the board for those who want to type it in. I didn't really use a conversion factor here, but if you want to convert, or the conversion factor I use in calculating the permeability. Okay, that conversion factor is from the units. You see that the permeability is in millidarcy. Millidarcy is actually expressed in the form of length squared. The units I was using in the calculation is centimeters, and the viscosity is in centipoise, the flow rate is in centimeters squared, and all that. You need a conversion factor to standardize all the units and make them consistent. In this case, the conversion factor is just 100. So you just add 100 to it, and you don't have to go converting all the various parameters again. All right. Thank you very much. I'll make the video available. Let's see if we can work through this. You guys did very well in the work you sent last week. I was really surprised that you did so well. I'm hoping that you'll be able to work on this as well. If you cope very well with this, and then the one we will do next week, then I think you are ready for this course and you will do very well.